Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I hope all of you are doing fine and staying safe. In our previous meeting, we actually discussed about different ways of making a local area network. We discussed about the networking topologies. There were bus topology and star topology, and there was ring topology, and there was hybrid topology. Today we are actually going to talk about transmission media. Now, what do we mean by transmission media? The physical means through which the data transfer is happening is the transmission media. By physical means, I mean that if two computers are connected through a cable and one of them is sending the data to the other and the data is actually traveling on that cable, so that cable would be the transmission medium. The transmission media is that communication channel which is connecting the sender to the receiver, which is carrying the data from the sender to the receiver. The transmission media can be wire based, wired, or it can be wireless. But in both cases, it is the physical part which is making the data communication possible. Whether the data communication is happening in the form of electromagnetic waves, or whether the data communication is happening through some wires, the physical path which is making the data communication possible is your transmission medium. Both of these transmission mediums, like wired and wireless transmission media, have their own characteristics, their own advantages and disadvantages, their own pros and cons. When you are actually talking about the wired transmission media, the physical mediums of the characteristics, like what kind of cable you are using, what is the strength of that cable, how long and how far it can carry the signal without deteriorating. These kinds of things are actually considered. And when we are talking about the wireless media, we talk about what kind of signals we are going to use, what is going to be the wavelength of our frequencies. In case of wireless media, these things become more important. Then there are some important terms which we will be referencing throughout the lecture. So we would first make our mind clear about them. First of all, there is bandwidth. And most of you have heard that term. But what it actually means, most of you have been using the DSL internet connection and you know about the different rates on which those connection operate. For example, if somebody is using a 50 megabits per second DSL internet connection, what that means is that internet connection is able to transfer 50 million bits in 1 second. That's the bandwidth. That's the amount of data which can be transferred from point A to point B within a network within a specific amount of time. The more data you can send in the lesser amount of time, the better data transfer speed you are going to have and the better bandwidth you are going to have. So the bandwidth is actually the amount of data which is being transferred from the sender to the receiver in unit time, and we actually measure it in bits per second. It can be megabits per second, and if you are working in your local area network, now we have the speeds of gigabits per second in our local area networks available to us. Then we have interference. Suppose your signal is traveling on your cable, on your wire, or maybe your signal is actually going wirelessly. in the form of electromagnetic waves. Or now what happens is that there is some other signal, some other electromagnetic signal, some high intensity power lines causing their own magnetic field try to disrupt your signals. Now that's interference. Disruption of the signal is interference. Addition of some unwanted signals into your data signals is interference. The less interference we have in our transmission medium, the better it is for us. If a transmission medium is prone to interference, we are going to keep facing the problem in using the network connectivity. So the more interference is going to actually cause more problems for us to use our network. Then we have another thing called attenuation. Attenuation is actually a signal being deteriorating, means a signal losing its strength over a distance. We are trying to send a signal on a cable, or we are trying to send a signal wirelessly. Excuse me. After some distance, the signal begins to lose its strength, the signal begins to lose its energy, and we need to install some sort of repeaters, some sort of boosters to actually keep that signal on maximum strength, so that when the signal reaches the destination, its integrity is still uncompromised. The signal is still readable. It is not corrupt. So the more attenuation rate we are going to have, the more need of repeaters we are going to have. So we tend to choose a transmission medium which have less rate of attenuation, which do not let the signal fade away, which keeps the signal at its strength as long as possible. And by long, I mean the longer distance, not the length of time. Then it's time to talk about the different types of transmission medium. As you might have guessed, according to my discussion up till now, there are two types of transmission medium, which is wired and wireless. In wired, the means we have is twisted pair cable, then we have coaxial cable, and then we have fiber optic cable. Today, these are going to be my main topic. In the next part of this lecture, which will be followed by a worksheet, we are going to also talk about the wireless mode of transmission, which would include radio waves, microwaves, and infrared. Since all of these can be the carrier waves of our signals, we are going to see them, how they transmit the signals, how they can be used as a transmission medium, as a way of sending the data, as a carrier of our data. So twisted pair cable. You might have seen this sort of cable, a pair of wires twisted together. That's why it got the name twisted pair, a pair of wires which is twisted together. And the insulation of the wires is their own. There is individual separate insulation on both wires, and then we are just twisting the wires together. And then we are going to see in just a minute that mostly they do not just come in a single pair, but they're bundled together. Two pairs or four pairs. Four pairs means 8 cables are going to be in one bundle. In most our local area networks, we use twisted pair cable. Local area network, you might already know this, but the local area network is actually a network which is in your school or at your home or in your office within a single building or a few buildings. In your schools, your computer labs are actually an example of local area network. If your using a network at your home where six, seven devices or two or more than two devices are sharing one internet connection, you are actually part of a local area network, a small network. So, excuse me. Local area networks are usually wired with the twisted pair cable because in shorter distances it has good performance and it is cheap and it is easier to handle. So we prefer the twisted pair cable when we are making the wired local area network. And it carries analog signals. If you look at this diagram, you would see that there are four pairs of twisted pair cables, and each of the pair there is always one conductor wire and the other insulator wire or ground wire, and then they are actually encased in a protective jacket, the cable jacket, to keep them protected and keep them together. Now, why we actually twist that? Because twisting the cables together actually increases the possibility that if there is some interference, some noise trying to interrupt the signal traveling in the wires, both the wire have the same level of difference in the signal. So uh, when the signal reaches the receiver, the noise actually is going to mostly cancel itself out and actual signal is going to reach the receiver. So twisting the cables together decreases the possibility of signal getting corrupted. This is actually another picture. You might recognize this little jack, which is similar to the telephone cable, telephone signal cable that you use at your home. For those who actually still use a landline, because now mostly people have switched to cell phones. But this is a little bigger size. This size is RJ45. Your telephone cable size is RJ11. This is how the twisted pair cables are actually wired into this RJ45 jack. Now, you don't have to actually understand or even memorize this sort of uh, cable arrangement. It is just there to make you a clear understanding that how the twisted pair cable can be used into making a networking jack, and this networking jack can be then plugged into the computer's network interface card and make the connection possible. As for the benefits or as for the disadvantage, as for the pros, a twisted pair cable is cheap and it is quite easy to work with. And as for the cons, it has low data transmission rate and it has shorter range. If you need to, for example, if you need to make a local area network in on the distance of 200 meters, so you will for sure need to install some repeaters to keep the signal strength at a readable level. Otherwise, the signal will keep deteriorating, keep fading away in the twisted pair cable, and it will actually be lost. This is actually a router, a DSL router. You might have those at your home, and if you look it up, you would see that there are at least four, or in some cases, 8 or 16 ports of wired connectivity, and you can connect a twisted pair cable with an RJ45 jack into these DSL modems. Now let's talk about coaxial cable. And I really think and hope that most of you recognize this picture. This is the same cable that most of us use in their homes to connect the cable TV to our television sets. As for the construction, this cable has first a plastic cover, then there is an insulator to protect the conductors from interference. Then this mesh of copper wire is actually an outer conductor, which is the shield. And then there is again a plastic insulation, and then there is the inner main conductor wire, solid round cable, which is carrying the signals. So it's uh, quite apparent and easy construction of the coaxial cable. The data transfer rate of coaxial cable is notably superior to the twisted pair cable. And its performance is limited by attenuation and noise. I should point this out that for any transmission medium, you will always be able to evaluate its pros and cons. Always try to see that if I'm using this thing as a transmission medium to make my network, what are the benefits I'm getting and what are the disadvantages I have to face. So always study a transmission medium according to this point of view. Then coaxial cable is quite versatile. It can be used to connect computers together. It can be used to distribute television transmission. Uh, it can be used to connect telephone lines. Although most of the telephone networks we see nowadays have been shifted to fiber optic. So how fiber optic actually transmits the signal? A fiber optic does not carry electromagnetic signals. It actually carries the signals in the form of light. There is a scientific principle. We would get to that in a minute. But this is actually a representation of fiber optic to get you an idea. These very thin light pipes are actually shielded with flexible buffer tubes and then yarns and then protective jackets. And inside all that protective layering, there is your hollow pipes of glass which are carrying your data in the form of the rays of light. You might remember the principle of total internal reflection. You might have studied that in your physics classes from your O levels, or maybe somewhere in AS, you will study that as well. But here you just need to know this, that when the light is actually trying to go from a denser medium to a less dense medium, then at a certain angle, where the angle of incidence is greater than the critical angle, rather than going into the other medium, it is reflected back in its same medium. And that's how the fiber optics operate. The light keeps reflecting back into the light pipe itself and it reaches its destination. This is actually the side view of the fiber optic. The ray of light is traveling within the core pipe, and there is cladding which is covering the ray of light from outside. That is actually the cladding actually is the less dense glass or plastic which is causing the total internal reflection to happen. As light is being the fastest thing available to us humans, The fiber optics speed is maximum in all the wired transmission mediums that we have. The fiber optic is the fastest. The data rate of fiber optics can go to the hundreds of gigabits per second, hundreds of billions of bits per second. It's smaller in size and lighter in weight, so hundreds of fiber optic cables can be bundled together to provide connectivity to more and more senders and receivers. The attenuation rate is quite lower in this, means the signal fading away in fiber optic it happens quite less. And since the attenuation rate is lower, we have fewer needs of repeaters. We don't need as much repeaters as we need with the twisted pair cable or coaxial cable. This is a comparison. As I was telling you that whenever you are evaluating your uh, transmission medium, always evaluate that according to the factors of advantage and disadvantage. What is the cost that you need to pay? Although fiber optic, as we discussed, is best of them all, but it costs highest of them all. And it is always requiring some special equipment and some technical skills to handle that. So, this is actually from your textbook. I would hope that you study your transmission medium topic. In our next meeting, which would be the second part of this lecture, we are going to discuss the wireless transmission mediums. And now we are going to move to question answer session. Thank you very much. See you in the next lecture. Allah Hafiz.